Okay, so we have this really pretty awesome data structure, really, based upon a named tuple. We have a way of instantiating it using this class. It's pretty cool. We really got a lot of stuff going for us, but there's still some really weird problems with it. And that is, like, if I misuse this, for instance, if I say I'm going to create a new state and I'm going to set quit equal to the string true and not the true value, nothing happens. The Python will not generate a runtime error if we assign an incorrect type. So you're thinking, well, why do we have this? And so it is frustrating, I agree. So let me show you an example program. This is the whole program here. I am instantiating, I'm defining the class. I'm importing from typing what I need here to use this syntax, and I'm able to instantiate a new state where I'm saying quit is equal to the string false. And it would be so easy to make a mistake like this, especially in a very large program. And if I print the state, it doesn't print it very well, and I can't use pretty printing here either. I'm still going to get this kind of an output. So we just have to look at it like this. And what we see is that quit is a string value, even though quit has been defined as a Boolean value. And this is quite frustrating. But we do have this tool called MyPy, and if you haven't installed it, you're gonna need to install that. You can use pip install MyPy, and if we run MyPy on this program, which is called typehints, we do see that at line 16, argument quit to state has incompatible type string expected bool. So that's how we can use this information to write better Python programs. So here, if I correct the program, this is what was going on. This is what we're trying to fix. If I set quit here to be equal to true, which is actually a Boolean value, and now I run MyPy on this other version where I've fixed this, it will tell us there are no problems. Just because it doesn't find problems doesn't mean that your program is perfect, truly. But MyPy can find a lot of problems, and it can really help you to ascertain if your program is actually correct if you use MyPy in this way. So that's one of the things that we're getting by using this kind of complicated data structure with all these type hints, is that we can use MyPy to see if we're making silly mistakes. Now, I think the elephant in the room here has been all along that I keep stating that this idea that this object is immutable. The state object is going to be immutable because it's based on a named tuple. And so why would I want to use that? So I mean, like, right away from the beginning, we need to change the state of the board from all dots to X followed by dots, because X is taken cell 1. And so if we try to set the board equal to this list, we're going to get this attribute error. This is an exception, and we can't set an attribute like this. So how do we go about changing the state? Well, this is very much how we've had to deal with changing strings in the various exercises that we've had. You can't directly mutate a position in a string, but you can set the string equal to a new value. And so one of the things that we've done is, for instance, like in the telephone game, we might have taken a string slice up to the character that we wanted to mutate, then we had some sort of mutated character, and then we took a string slice from that character afterwards, and the rest of the string, and overwrote the string to be that new value. We did those kinds of things many times in different exercises. So what we were going to have this variable called state, and we're just going to simply set state equal to a new value, where, for instance, we could say state is equal to a board where it's now set to this new list. This is the new value for the board, and we're setting the player equal to O, and we're going to set so we're pretending here that player X has gone first and is taking cell 1. So we're setting the board to be the new version of the board. We're setting the player to be O, and we're going to set quit to be equal to whatever's the current state of quit. It's because we're not changing those values, so they're just going to be equal to whatever is the current value. What's nice, though, is that named tuples have this built-in underscore replace. Sorry, I'm baking bread today. And so it has this underscore replace method where we can say state is equal to state replace, and we'll say the board is equal to this new value, and the player is equal to this new value, but everything else will just be left the same. So it's a much easier way of writing this idea. And so that's how I would recommend you use this. So again, thinking how you're going to have this infinite loop that you're going to have for your program. And inside of that loop, you're going to have to keep track of all of these ideas. Maybe you're going to keep track of them differently. Maybe there are more or fewer fields that you want to keep track of, and so you should modify your version of state to be whatever you want. Here I'm going to keep track of these, and this is the way I'm going to do it. And when I want to update my state, I'm going to use state replace. And so in here we see that now state has been updated, and quit was false and draw is false because those were the values from the previous version of state. And that's how I'm going to keep track of how my state changes on each turn. So think about those ideas.